Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss scientists warn of the sun's instability after a star eruption. Astronomers have issued a dire warning about the sun and cautioned about its instability. It comes after the eruption of the Dragon Star, or EK Draconis, a G1.5V yellow dwarf located 110.71 light-years away from the Earth. Scientists have highlighted that solar flares lead to mass ejections that directly affect the Earth's environment. This kind of big mass ejection could, theoretically, also occur on our sun. This observation may help us to better understand how similar events may have affected Earth and even Mars over billions of years, said co-author Yuta Notsu from the Laboratory for Atmospheric and Space Physics. The study published in the Nature journal shows that M-type red dwarf stars are not as stable as previously thought. However, the sun appears to be far less active than similar stars in terms of brightness variations caused by sunspots and other phenomena. Researchers said that an examination of 369 stars similar to the sun in surface temperatures, size, and rotation period, it takes the sun about 24.12 days to rotate once on its axis, showed that they displayed on average 5 times more brightness variability than the sun. This variability is caused by dark spots on the surface of the star rotating in and out of view, said astronomer Timo Reinhold of the Max Planck Institute for Solar System Research in Germany. The sun, essentially a hot ball of hydrogen and helium, is an average-sized star that formed more than 4.5 billion years ago and is roughly halfway through its lifespan. Its diameter is about 1.4 million kilometers. Its surface temperature is about 10,000 degrees Fahrenheit. Temperature and rotation period are thought to be the major ingredients for the dynamo inside the star, which generates its magnetic field, and eventually the number and size of the spots, causing the brightness to vary. Finding such stars with very similar parameters as our sun, but being 5 times more variable was surprising, Reinhold said. Elevated magnetic activity associated with sunspots can lead to solar flares, coronal mass ejections, large expulsions of plasma, and magnetic field from the outermost part of the sun's atmosphere, and other electromagnetic phenomena that can affect Earth, for example, disrupting satellites and communications and endangering astronauts. A much more active sun might have also affected Earth on geological timescales, paleoclimatology. A too active star would definitively change the conditions for life on the planet, so living with a quite boring star is not the worst option, Reinhold said. The researchers compared data on similar stars to historical records of the sun's activity. These records included about 400 years of observational data on sunspots and about 9,000 years of data based on chemical element variants in tree rings and ice cores caused by solar activity. They indicated the sun has not been much more active than it is now. The findings, Reinhold said, do not rule out that the sun may be in a quiet phase and may become more variable in the future. Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast.